Okay, so this is going to be the second part of the paper 1 for the physics specimen paper for 2025. So let's begin. So this question is about simple harmonic motion, which is subtopic C.1. It says a particle undergoes simple harmonic motion of time period t. At time t equals 0, the particle is at equilibrium. What is t when the particle is at its greatest distance from the equilibrium? So we know that in simple harmonic motion, the period is uniformly distributed. So at t equals 0, the particle is here. Then at t equals t over 4, the particle will be here. And then at t over 2, the particle will once again be here. And now here at 3t over 4, the particle will be here. And at t, the particle will once again be here. Now we can see that the maximum displacement occurs here or here. And as 3t over 4 is an option, our answer must be C. Okay, so this one says, diagram 1 shows a variation with position of the displacement of a standing wave formed on a string. Diagram 2 shows the variation with position of the displacement of a traveling wave moving to the right along a string. P, Q, R, and S are points on the string. What is the phase difference between P and Q and the phase difference between R and S? So one key thing you must know is that a phase difference on a standing wave can only ever be 0 or it can be pi. This means that the phase difference on a standing wave depends on the number of antinodes that are between the 2 points. If the number of antinodes between a point and another point is equal to an even number, then the phase difference is 0. But if it is odd, the number of nodes, but if it is odd, then it is equal to 1. So for example, this point and P would have an odd number of nodes between them, so therefore they would be out of phase. But this point and P would have an even number of nodes between them, 0, and so would be in phase. Now you can see here that P and Q have no nodes in between them, and so the phase difference between P and Q can only be 0. Now on this traveling wave, you can see here that 0, the first root is there, and then there are 4 more lines, 1, 2, 3, and 4, till the second root. Now you need to know that each one of these comprises of pi radians, because an entire oscillation is 2 pi, so half an oscillation must be pi. And you can see that this here is equal to half the length of the total here, based purely on the number of lines. So pi over 2 must be the phase difference between R and S. So this is satisfied only by these two options, which means that answer C, which satisfies both the criteria, must be the correct answer. Now, this question says a mass of 0.25 kilogram hangs from a spring of spring constant 4 Newton meters. What is the natural frequency of oscillation for this system? So we're given that T equals 2 pi root m over k. Therefore, we're also given that frequency equals 1 over period. So if we simply substitute into the first formula, we get that period is equal to 2 pi times square root of 0.25 over 4. If we simply evaluate this into our calculator, we get 2 pi times square root of 0.25 over 4. We get pi over 2 is equal to t. So now frequency is equal to 2 over pi, which is around equal to 0.6366 hertz, which is 0.64 hertz. Now, this question says light from a monochromatic source is incident on a single slit, and the resulting diffraction pattern is viewed on a screen. The graph shows the variation of intensity with distance on the screen. the intensity of the source remains the same, the width of the slit is increased. Which graph correctly shows the variation of intensity with the slit after the change? Okay, so for this we just simply go to C.3 in the data booklet and we see that theta equals lambda over b, where b is the width of the slit and theta is the angular separation between the fringes. So if we increase the width of the slit, then the theta will have to decrease as b, the denominator will increase. The wavelength is always a constant, so theta will decrease. So if here we increase the width of the slit, then b will increase, so theta must decrease. So now we're looking for something which has the exact same intensity, as the intensity is not affected by the width of the slit, so we can rule out option C and option D. So we're left with B and A. Now, as we said, the angular separation of these must be less than it was before. In B, it's more wide, so it must be more spread apart, which is definitely not true, as we just proved. So the answer must be option A. Question 23 says monochromatic light is incident on a diffraction grating. The diffraction pattern from the diffraction grating is then formed on a screen. Only the central maximum and the first order maxima can be observed on the screen. What change will allow the second order maxima to be observed on the screen? So the equation for a diffraction grating is n lambda equals d sine theta, which is given in the data booklet, so you do not need to memorize it. So it's this. So the first one says decrease the distance between the diffraction grating and the source of light. Nowhere on this equation does it mention big D, which is the distance between this grating, and does it mention the distance between the source and the grating. So option A is instantly wrong. Now this says increase the distance between the diffraction grating and the screen. Nowhere in this equation does it give big D, which is the distance between the slit and the screen. So this is not given, so B must also be wrong. And C says increase the wavelength of the monochromatic light, and D says reduce the number of lines per length unit on the diffraction grating. So we're looking at something that will minimize the angular separation, and as D is inversely proportional to sine theta, we know that the bigger D gets, the smaller sine theta gets, and theta is directly proportional to sine theta, and increasing the angular separation will only decrease the number of slits that we can see. Therefore, we must try and decrease the angular separation. So as theta is directly proportional to sine theta, and we decrease sine theta by increasing D, option D must be the right answer. I hope this helped. The next part will be coming out soon.